Thank you very much for the introduction. I'm Veronica Schmidt.
Emily Butterfield.
And we're very excited today to talk to you guys about probably an argument we've had for about a year.
More,
probably.
More, I think.
So how did this very strange topic come up? Well, needless to say, on a train ride to Germany. We were doing a workshop on medical device forensics, and Emlyn came with a very perplexing question.
So really, we panic, we worry a lot. I mean, forensic continuously changes. What we analyse continuously changes, or it feels like it does. And Veronica loves to play around with medical devices, analyse medical devices. And she's got a very, being a bonnet, maybe the wrong term, about medical devices and how unique they are and how hard they may be to analyse and extract data from. And we always go around in circles in discussions about how to extract data, what's the best way, what's the best approaches. And actually, my argument, and usually I win the arguments, is that emerging technology is probably a better description than just medical device forensics, because what we see is new technology, new devices, new things to look at.
The question for me has always been, well, I grew up in an industry where we had vehicle forensics, mobile phone forensics, we had medical device forensics, but everything kind of started going together when I started teaching more. When I had to teach others how to do what I do, and not just view my little world of specialization, as I call it, or my skill set, I started to see that, unfortunately, Emlyn had a point. And although I don't like, losing, I have to concede that emerging technology forensics is perhaps a better term for what we do.
Because really what we're trying to look at in this talk a little bit is what is new today, old tomorrow. So things change, things evolve. Does it actually impact us significantly because it becomes old, or does it become old really quickly? Hopefully, we'll answer some of that.
So who are we? Well, I'm Veronica Schmidt, otherwise known as V. I am an assistant professor at North University College. I'm also currently doing my PhD in cybersecurity at the University of Plymouth. But I think one of my biggest things is I absolutely love DFIR, and I've been doing it since 2008, and it's something that I'm happy to always talk about and complain about and vent about.
I'm Emily Butterfield. I'm head of computing here at North University College. I'm also the program lead of the digital forensics degree that we have. My focus, my passion, the things I like to analyse are more mobile related, application related, and the kind of data we can get from that and connecting the dots between the data. So between us, we bounce a lot of technology between us and how we analyse the data, and we come at it from different angles, which means we usually end up looking at the whole ecosystem, I think it's fair to say.
And I think it's like the perfect synergy, because I absolutely despise doing mobile phone forensics, and he has converted me to the point that I now start looking at medical things on mobile phones. And not a day I thought would come. But I think we started to see that in isolation is not where we want to be. We want to be able to see the big picture.
And I think that's where the talk kind of came from, or our whole discussion, which kind of led into a talk of, can we work together better? Can we look at technology in a different light and remove our blinkers? So can we look at it in such a way that anything's possible? Anything can be recovered, anything can be analysed, and actually it's not as scary as it needs to be.
The other question that we always come up with between the two of us is this really something that's new? Is this new skills? Like, is this having to pick up something we've never done before? Or is it simply something that we can take the DFIR techniques we've come to love and have fostered for years, and perhaps translate, bend, mold, and turn it into a different technique that is still the same? Is there actually a foundation to build off? Or are we scratching digital forensics and incident response every time something new comes out?
So we're also going to look at, can we just translate those older skills, the traditional skills, and for those who've been around a while, just simple hex analysis, does that translate to all new technology, all emerging technology.
But I mean, if we ask the question, let's put everyone in the mood before we start. You receive a new case. Your boss brings a case and he says, okay, you need to go to the morgue. Right. And in the morgue is a dead body. Inside said dead body is a pacemaker. Would you immediately know what to do? Would you be scared?
What's that for me? Sorry.
Yeah, it's for you, drinking your coffee. Would you be scared? Would you be worried? What kind of the audience can answer as well? What would you do?
I think in most cases, there'd be a bit of panic. Because it's new. But if you never touched it before, you never looked at it before, then it is a little bit terrifying.
Would you be shocked to learn that the data that's contained on it is all made of bits and bytes?
No.
But it's things we know. It's just kind of covered in a new shiny package. But it literally isn't anything so, all-breaking.
We hope.
So to understand emerging technology and what it is, I think we need to look back. History is always a good place to start. And a lot of these dates are in the kind of ballpark of where we could find some academic papers that supported it. But if we start right at the beginning, when the first kind of case for personal computers were examined, that's back in the 1980s. And I'm pretty sure when that came out, everyone thought that it was emergent tech. Everyone thought like, holy cow, how do we do this? I mean, what do I even, get from this information?
You might not, but when you move from that personal computer into PDAs, those fancy things that you looked really good carrying around a PDA with a little stick and you could write and you could do anything you wanted on it. That was amazing technology. And again, trying to extract that, and the tools weren't available. We couldn't just do a simple extraction. And sometimes we had to go back to the old school of just taking photographs.
And I mean, then the internet and sat-nav and vehicle forensics all came about. Then we started being able to put people in places. We started being able to actually track where people have driven, what they've done. We've also seen more communication between people with the invention of the internet. Things started to become connected.
Yeah, so now we have mobile phones, and those mobile phones, for those of you who remember extracting information from Nokia 3110s and any kind of new device, it wasn't easy to do. And we had to find new ways of developing techniques to extract, to analyze, to interpret, to make sense of the data that was on there.
Now, if you take the journey then, that's when medical devices started to actually become interconnected and smarter and contain more information and more integrated into hospitals. So now you have a situation of, we have these devices that are keeping people alive, but how long was that new? Not very long, because it's in 2007 already, and we're now in 2023. So medical devices really aren't that new anymore.
And I think what we've seen throughout all technology is that it's increased, it's ramped up in speed and new devices that are released. So we have phones, we have computers, we then move into IoT, the buzzword, the sexy words of these small devices that could be anywhere distributed. And they have capabilities that come from anything from cameras through to speakers and anything else in between. They have data that might be relevant, and they still pose problems to doing extraction. But they also store information not just in themselves, but elsewhere.
And I think in the next step was the boom of the cloud, where everything became interconnected, and your medical device was talking to mobile applications at the nurse's station. Your mobile phones were connected to your smartwatch or your Alexa or any of these devices. But I think the takeaway of this slide is that emergent technology has been around for years.
I think every year, every time a new device is released, it's an emerging technology. And we have dealt with emerging technology all the way from day zero. So from the first point that a device could be used for an investigation, that was emerging technology. And we have just continued to evolve and build upon it. And everybody within DFIR has learned to deal with different tech, different ways of extracting, different ways of analyzing and determining what's contained on the device.
But if you think about it, it's more than just emergent technology. It's kind of continuous learning.
Yeah.
Every device or every case that comes across your table, there isn't a recipe in how to investigate it. There's no recipe in what you'll find. Yes, you might understand the file system or operating system on the hardware, though there are some things that don't change. But every new case brings the opportunity to learn.
Tech is tech. Tech is tech, and tech is built on top of tech that's been around for a long time. Just the way that we interpret and the way that we have the confidence to interpret and extract that data.
So maybe another term is emergent learning.
I like that one.
So let's look at the evolution of DFIR, and we might be giving away our ages here, but we started with a single computer investigation, whether that was just a computer, mobile phone. It was always in isolation. It was always that single device that someone suspected the smoking gun was on. Inevitably, sometimes they'll get it wrong, and it isn't the actual device that you need. But
Small storage, not much on there, not much to worry about.
yeah.
But it soon changed. We then moved into multi-system investigations. We have devices spread across networks, devices that talk to each other, data that isn't stored anywhere that we can easily access.
Yes. If you think about, there's been an increase in terms of how many devices there are. Now, for everyone in the audience, how many of these devices do you own?
We'll assume you're saying lots and possibly all of these devices. And even if you think about what's on your person right now, likely it's going to be a number. I mean, sitting here, I've not got huge numbers, I made 3 today. Veronica's possibly got several more. But these devices we all have access to, and likely, just like everybody else, we all have multiple of them. You're not going to carry a toaster and a fridge around, but we all have other capabilities.
For me, I have my mobile phone, I have my watch, and I have my implanted cardiac device. So one could say that I'm a walking, talking ecosystem on my own. But so is everyone. Every person owns more than, let's say, 3 of these things at any given time of walking around.
But when we look at the underlying technology, when we look at what's underneath them, they're all bits and bytes. They have to be. That's how it works. They are all stored in the data stored in some kind of storage medium. That storage medium may change. It might be different depending on the device. But we can go back to our traditional SD card.
Now, everyone knows this. Everyone has most likely once in their career, at a minimum, done forensics on one of these devices. It's nothing new. It's nothing strange. The sizes have changed. They've gotten smaller with more storage capacity, but in essence, what is contained on it is still bits and bytes. And what does digital forensic practitioners love more than bits and bytes? Well, I don't think there is anything. Well, where do these come from?
Or where do we find them?
Well, it started with cameras. Cameras had these, mobile phones had these. Would you be shocked to find out that most medical equipment had one? They use this as alternate storage. Drones have them. So they might come in a shiny package, but under the hood, not so emergent as we think.
Yeah, and I think that's possibly one of the key things is that these different pieces of technology, because they use this underlying old school tech, is probably a better word to use, but we know how to extract the data. We know how to get it. We know how to take data from an SD card. It's probably the first thing that we all learned to do was how to use a write blocker, extract the data, and take an image. That's not a fear. The fear is when you look at a CPAP machine and think, what do I do? I've got a mask. I've got a device. I've got something. It beeps and there's flashing lights. What do I do? Well, when we pause and we take a breath, what we realize is actually, well, maybe things aren't as difficult as they need to be.
No, always go read, always go do your research, as we've done for years. All of these devices have got manuals, and within said manuals, it will tell you very nicely what is contained on the inside without even ever having to open it. Now, if you think about, oh goodness, this must contain some foreign file system, you'll be very shocked to know that most CPAP machines have an SD card that is FAT16. Now, FAT16 has been around before the crows have come home, and it's something we've seen and done. But if you think about even your PDAs ran some flavor of embedded Windows. Windows is something we're familiar with. A lot of drones, BusyBox, which is Linux. Nothing new. So if you start breaking down to what you know, meaning what is the hardware? Well, it's got storage that we know. What is the file system? Well, most likely something you've encountered. Is there an operating system? Well, yeah, sometimes you'll find, shockingly enough, it's something that you know.
But the new is, it looks new, it looks shiny, it looks different. I've never come across it. It's new, it's emerging technology. But then when we take that step back and we realise I've spent an hour or two researching into it, tomorrow that new technology is now old. It's using old tech, it's using old skills, it's using our traditional skills.
So digital forensics is something that has been around for years. It's something we've been doing, perfecting, changing, ever evolving. Now, the use of write blockers, whether a software write blocker or a hardware write blocker, is nothing new. At some point, it was new. At some point, it had to be used for the first time. Much like anything in life, the first time is always the hardest, and after that, it's old. It's old news. So traditionally, we would use write blockers.
And we would we'd strip a machine down, we would extract the hard drive, we would identify any kind of storage medium. And ideally, we hook it up to your write blocker. And then we would create a forensic image and we have our secure copy. That was our traditional steps. And those traditional steps generally are still around now.
Yeah, and it's a single system machine often that we are looking at that doesn't have a lot on it except what is stored locally. So again, nothing new, nothing we haven't done. It might just be a different way of looking at things.
And traditionally, these are limited network connectivity, which means the data was stored locally. There wasn't necessarily anything stored in a big server farm anywhere. The data was just here. We didn't have to worry about network connections, how data is shared, how data could be intercepted or modified remotely.
Traditionally, we do operating system forensics. Our forensics would be guided by our knowledge of the operating system. Now, whether that's Windows, Linux, Apple, that kind of each had their like secret recipe that we would follow. We'd know where to go look for things. But the amazing thing is someone had to reverse engineer that to do it the first time. So at some point when Windows 11 came out, it was emerging tech. Today, well, it's not as emergent anymore, which kind of supports the hypothesis that nothing is new for a long time.
I think that's a key. It's new, but not new. It's old, becomes old very quickly. So has it changed? Has everything changed? Has what we do as forensic examiners changed? Is it the same? Have we had to evolve? What?
I mean, I want to be very snarky and say it depends, which is the ultimate answer to everything. But I think there's some portions that's changed. But I don't think in essence it has changed that much. If we think back to the things that we had there, use of write blockers, well, maybe that's a little bit difficult when we're talking about things that are embedded or different storage mechanisms. So I think that might change, but for how long, I don't know, before someone develops some mechanism to write block doing onboard forensic acquisitions. Our type of forensic images maybe have changed.
Is it more of an evolution?
Yeah, I don't think it's changed. I think it's evolution. I think it's the natural way of things, as we started with DD and we ended up with all these various ones we have now. Everything changes, everything evolves.
So would you say our traditional DF techniques are still used today?
Yes, but I think we need to define what we mean by emerging technology. And I think emerging technology is the shiny thing that we expect is absolutely the latest and greatest thing. I mean, if you think about sliced bread and toast, it was new at some point and it was emerging. And I think sometimes we put these big shiny things on new things, not realizing that they're actually old, they just have been evolved.
Mm-hmm. So it's our chance really to look at using the skills that we know, using the things that we already know, the way that we already do things. Most of the technology isn't new, it's just built upon what was already there. And we can therefore use our capabilities, our understanding of how technology works to interpret and to analyze that data.
If you think about emerging technology as the new thing that is going to change the status quo, I'm going to use the example of the pacemaker. If you go Google the history, you'll realize that this thing has been around since before I was born. What has emerged? The battery capabilities, some of the functionalities, some of the security, but in essence, it's still the same. So it didn't necessarily change the status quo every time a new one came out.
Is it possible then that emergent technology is less emergent and more capabilities are realized?
Yes, I think it pushes us as digital forensic practitioners to learn, to grow, to evolve.
Because we realize what's possible now,
Yes.
whereas we didn't necessarily realize before. All we thought about when we did forensics was computer, phone, servers, maybe networks, that kind of stuff.
Okay, so let's look a little bit about, we spoke about the synergy between users and the devices. And this is traditionally what you might come across in an investigation. You might have an individual that owns a desktop, laptop, both sometimes mobile phone.
A watch, a tablet, an iPad. They store things on the cloud. And they're kind of, I think they're fairly common. And we class them as common devices. And we understand, using all the different tools that we have out there, how to extract the data and how to make use of that data. A thing that maybe stands still a little bit on the scary side is like the health-based data, health-based devices. And that can be the pacemaker, the CPAP machine, insulin pumps, even just your watches that you wear. The kind of information that can be extracted from that isn't necessarily fully utilized or realized yet. But what we see is that when we've moved away from a single device, is that each and every one of these devices stores a significant amount of data about the user. And it's increased year on year as we start to use devices more.
I kind of want to use the example of building a puzzle that's all gray, right? You don't have the full picture, so it's very difficult to put everything together. Like maybe for some people that are smart, they can do it, but as things have become interconnected and we've seen the bigger picture, that's like turning that puzzle around and now seeing little fragments of the story emerge throughout the ecosystem. If you think about how watches track you and research that has been done, you can do like a pattern of behavior, pattern of daily routine.
Would you say the difficulty isn't necessarily about how to analyze these devices? It's about how to connect the analysis of these devices. And actually the hardware, the tech behind it all is similar, but the ability to connect the dots between 6, 7, 8 devices for each individual is actually where the challenge exists.
Yeah, I think it's less about the individual devices and more about how they connect together, because they're storing fragments of the story. One needs to figure out how they correlate, how they trace, how they fit together. And if you think about just like a pacemaker, for example, it communicates with sometimes a home monitor, which communicates with an application, which communicates with the cloud, and. So you might just get like the bare minimum story if you look at things in isolation. So I think the big evolution here is that individuals need to evolve their way of thinking in a bigger picture.
And develop that ability to connect the dots. But traditionally, we had specialists who did each of these individually. Is that still the case?
I think one could make the argument that things are smaller, which some of them are more complex. But I think it's not so much about a specialism, because you will encounter a large portion of these in each investigation. Now, if you don't know how to, at least at a basic level, see how things fit together, you are going to miss fundamental things. So is it a specialism? No, because I think everything is new when it comes out the first time, then it's old, then it's been done. But we're still following the foundational skills in digital forensics, which is finding the binary trail, reconstructing what has happened. Those things haven't changed.
But what is the complexity then? Just because it's smaller, why is it more complex?
Because I think it's having us lean into skills that traditionally we didn't need to do.
Mm-hmm.
Which means that maybe DFIR is in need of an evolution in terms of embracing skills that are not purely DF.
Yeah. So You've already kind of suggested it, but do we need specialisms? We also, I remember when I working in industry, we had people who specialised in fonts, people who specialised in computers, and the two didn't really meet, not at the beginning at least. But do we need those specialisations? Do we need someone who specialises in medical devices? Do we need someone who specialises in IoT?
I don't think so, but I think what you will have is people that find a niche and become experts in it. The courts will deem them an expert in it, which is nothing new from what it is today, because you have people that are experts in incident response. You have people that are experts in malware. And these are not specializations on their own. They fall under the umbrella of DFIR. It's skills that at a minimum, most of us can do. I mean, if I have to, I'll do mobile phones, but I'm going to do that under duress because it's not something that I love and it's not something I want to do, but it's a skill that I have because it's DFIR. But the same with medical devices. Police might encounter it, and it's something that at a fundamental level we should do. But I don't think we should break up digital forensics and incident response into these small specialisms that each now follow a new process, because that would mean that the forensic process doesn't apply.
So would it be fair to say then that everybody should be able to analyse all devices to an extent, or have the ability to analyse all devices, with people who have some extra learning, some extra competence in particular devices or particular systems or particular technology, who can then assist other people in getting the best from that?
Yeah, and I think for me, the important thing why I love digital forensics and incident response was because I was forced to learn. It's a continuous learning. It's not today you do it and you know everything. The more you learn, the more you realize that there's so much you do not know. So I think it's nothing new, it's nothing strange. It's just us having to go through the normal evolution we've been going through for years.
So we don't need specializations. We just need people who are competent.
Yes.
And people who are willing to learn and develop and pick up skills and be willing to share those skills with other people.
Yeah, I think that's the important thing, is how do we transfer these skills? One of the things as a community, SANS is a great example of that. There is a lot of people doing amazing things, whether that's dragging a pretend dead body, whether that is chasing someone in Bletchley Park up and down on monitoring an iWatch. Everyone does cool things, and I think talking to each other and sharing is one of the ways to go. And also not being afraid to fall on your face and say, I failed, and share it, because that means someone else learns from your mistakes.
So we're not really worried about the technology. What we're worried about, what we're thinking about, is how can we deal with this new thing, this new device that might come in front of us? Can we use the same techniques, the same skills? We've already said we can. So it's not about the panic. It's not about building specialisms and elitisms within units. It really is about developing and upskilling people so they can pick up any of this technology and make sense of it.
Yeah.
That's what we want to try to reimagine.
So what is the impact on DFIR really? Well, I don't think it changes the status quo for us. I think it reinforces that we have to learn and evolve. And perhaps DFIR is at that kind of point where a big evolution is going to happen, where we start seeing that the world that we thought was at the end of its capabilities is going to widen open. And we're going to see that there's so much more to learn, so much more to do. But the impact is more on, I don't know, the joy of learning. That's the impact I'm excited about, because I'm forced to learn. I'm forced to pick up new skills that I couldn't do. And I think sharing, if we don't share, that'll have a negative impact.
I think it's easy sometimes just to get your head into cases and do investigations and extract the data and make sense of what you've already done before, and leave the harder stuff, the new stuff, and kind of avoid maybe touching it, let someone else play with that. But I think what we all need to do is pick up the willingness, the intrigue, the thing that really got us into forensics, and do that digging and pull it up the bits and bytes and make sense of it. That's where we need to evolve. We need to develop that learning, that inquisitiveness, because what we will then see is that this terrifying technology that's coming up tomorrow, it's actually just old hat tech, old hat ways of doing things, just reimagined into a new way, slightly new process, maybe a slightly new interpretation. Maybe it's just an extra step.
I mean, reading is a big thing. I mean, there's new academic papers coming out every day. There's amazing blog posts. I mean, if a new device comes out, if I'm curious, maybe I'm a nerd and I'm going to give that away, but I go read the manual. I go look at where people on YouTube take them apart to see what's inside. I want to know what makes it tick. And more often than none, I'm very disappointed in realizing that it's nothing new. It just looks shiny. But ways to keep up is to do your research. A simple Google search, a conversation, have those arguments. You don't have to agree. We didn't agree for a year. But the important thing is sharing.
Yeah, and willingness to share. We will all be able to bring something to the party. Encourage those who maybe are new to the field, who have different ways of thinking, who want to try something new. Encourage them to fail. Encourage them to find the faults, to find different ways of doing things that we've been doing for years. Because that's the only way we're going to keep up with this technology that hasn't changed significantly, but the new ways of connecting the dots and bringing it together is what we're looking at.
So the need is for a new DFIR practitioner of tomorrow.
Yeah.
Maybe.
Nothing stays new. Everything changes. And it always has done. All this technology that's coming now is just coming quicker than it ever has done. And we will encounter it more because people are realizing how much data, how much of a goldmine all this technology is to every single forensic investigation. And that's what is making all this tech become new. It has been around for a long time, as Veronica said, pacemakers, CPAP machines, it's all been there, but we hadn't realized what it holds and what it can be used for. Therefore, we need to realize that we can just use old techniques, traditional systems to extract them.
So all the skills you own, like everything you've learned, whether you're new, whether you're old, whether you've been doing this since, the 60s and 80s, doesn't matter. Those skills all can be tweaked, but it's more about the willingness of adapting. It's the willingness of change. I know people don't like change, but technology is changing at a fast pace. It is evolving. Therefore, it's a requirement for us in DFIR to evolve equally fast, which means we might have to tweak the way that we do a forensic acquisition. We might have to tweak the type of data that we have grown to love. We just need to maybe adjust and evolve appropriately and be willing to.
Don't be scared to try. Don't be scared to fail. Document that failure. Share it with the community, because then everybody can grow and we will all benefit from that.
So I wanted to end a little bit with two quotes. And this is from William Blake, and it basically talks about what we've said, that at some point someone thought that a pacemaker was impossible. At some point electricity was impossible, or the internet. But once it's been done once, it became a reality. It became something that exists. So things might seem new, but it takes one person to do it successfully for everyone else to not be afraid. But if that one person doesn't share it, then it remains something that hasn't been proved yet. Probably my favorite one comes from Marie Curie, who lived a life where she kind of challenged and evolved the world in her time, but nothing in life is to be feared. It's only to be understood. Now is the time to understand more so that we may fear less. Emerging technology seems scary. Medical devices, vehicles, drones, for me, mobile phones seem scary. But once you understand the unknown doesn't become as scary anymore.
Data's data. We all enjoy data. We all enjoy analysing the data. All this new technology actually gives us different opportunities to analyse that same data in different ways.
Now, if you have any questions, please feel free to pop it in the chat, or actually find our emails and email us a little OSINT challenge. Thank you very much.